And I'll take a stab at the third one, see if I could get that ready by the end of the day.
The
So
problems, are those the ones that Homer had put up earlier?
yeah, I ran through the second one and it looks like I came up with essentially the same solution as him, so no point in really going through that again. But I would like to see Justin's solution for the first one and Phyllis's. I know the first one was kind of a doozy.
Yeah, I couldn't figure it out personally.
And after we go over these two solutions, we'll jump into classes. Um,
Oh, Julius, I didn't actually come up with the solution, so we could just look at Justin's because I was planning on like if no one had it done, just like doing it live. But if
oh,
Justin has it, that's great.
okay. I guess you're off the hook now that Justin has a solution.
Matt, sorry about that. I was in the middle of rebooting right when we logged on. All right, here we go. Everybody see my screen or no?
Mhm.
Border. Okay. So basically, um, if we put in, um, I'm trying to remember the challenge now. Can somebody paste that in the thing?
Sure. Grab this. Let's paste this here. Oops. Oh, Jonathan beat me to it.
Okay. Is it in the Zoom chat?
Yep.
I'm running on one monitor, so hang on. All right, got it. So basically for this, I created a function, all password, with parameter characters, created a new list, and then uh, created a res to store all the combinations. And so with that, the defgen will then act as a helper function, and it will perform most of the recursive stuff. So to do that, I took two parameters, P being the path or the partial combination
Hmm.
of the letters, or I guess strings, and then rem being represents the characters remaining to be added to the list. So the recursion here, um, so if the current combination isn't empty, add it to res, and then check to see if it's length of one or more in the res. And then, yeah. So from there, we can,
I'll be right back. Someone's at the door.
Sure.
And so there's the output right there, where
Okay.
it takes all those and concatenates into a list.
Can we add to your print statement the length of the output?
Maybe if I learn how to do this.
Oh, sorry. In Python,
So
it's len,
it's huh?
it's len, and
Right.
it's a,
Or no, I got it. Is that correct?
no. You have to wrap len around the entire thing because all PW is it's itself a function, right? So that's a function that's essentially going to return a list, and so you could run the len function on that list. Print, it's also a function, so you have to still have parentheses around len. I think that
Oh my God. 2, 3, 2, shouldn't be there. All right.
cool. All right, let's see it with a 5 character string now. So any 5 letter word of your choosing. This is a really interesting challenge. We haven't even gotten around to like looking at potential edge cases because depending on how you write your functionality, what happens if you have a word with repeating letters, for example, right? But before we look at that edge case, let's just start with a regular or, well, a 5 letter word without any repeating characters.
We could do like A, B, C, D, A, B, C, D, E, F, G, whatever.
Yeah, that's fine too.
So you think this will break it? Is that what we're doing?
Yeah,
Okay.
I think it's limits. Okay, wow, it works.
I was like sweating. I was like reading the code, like I think this will work, but maybe he sees something I don't. I was trying to prepare myself, but I didn't see anything.
No, that's good. That's actually the same result I got when I ran through it myself earlier. Um, and I remember this because I had a few attempts where it was actually repeating results. So like my first outcome was like 1920, and then I was able to whittle it down to like 600, but that was still wrong. So this looks good. Talk us through your base case and how you worked from there to come up with a solution.
Yeah, so again, it's for the characters in REM. I basically worked from there and using the new path like P plus REM, I add the character uh, rem index to the current path, and then I use P there to create a new path. And so then I take the remaining and then use like the split method and then the split method plus 1. Then that created a new version of the REM by removing any characters at index I.
Okay.
So then that slice operation results in a new list. uh,
Okay.
to
Then
explore in the next recursion call, right? So
okay, that makes sense. But how would you state the base case in plain English?
really sure what you mean.
Right. So before you come up with a logic, right, and you're like looking at this problem, like trying to tackle it, you're like, I don't know, maybe you're pseudocoding or maybe you're trying to take an iterative approach at first. But if we think about recursion as being like the repetition of cases that get more complex, the simplest case is always your base case, right? So at what point do you end the recursion? That's your base case. When you're at your base case, you don't you're ending the recursion at that point. So in this case, when you're returning the final
So
result,
when P is empty is my base case. Right?
there you
So
go. Exactly. Yeah.
okay. Okay. I just wasn't sure what we meant exactly. Okay. So yeah, if P is not empty, then we continue the operation.
And again, P represents
I call it path, but it's just like the full list of characters in the original.
okay. Okay. Cool. Anyone have any questions?
So many, but I don't know how to ask them, so I have to just stare at this for a while.
Yeah, I had a question. How do you get it
Yeah.
from not repeating the same character?
uh, through the slice method. So when we slice, we append one at a time, and then it puts those in a particular order. And then as it loops, it checks against those. Um, I hope I'm explaining. I'm not super versed in this. This was not easy, so I hope that made a little bit of sense.
Well, did it?
Can you explain line 3?
Yeah. So again, when um, we take that if statement, so if P, the current combination is not empty, right? And then we add that to the res um, list, and then we check to ensure that it's uh, only the valid combinations, which would in this case mean a length of one or more, would be stored in res. And then from there, we run the for loop that iterates through each character in the REM and rem using its index. I think that was line 3. So this is Vim. So
Right. You have relative lines set.
yeah, which line is 3 now?
Right. I think it is it was technically line 7 that he was asking about.
Okay. So that one, the gen characters one.
Mhm.
No, it was line 6.
Okay. So
Well,
gen P plus REM. So basically P plus REM index adds the character REM I to the current path, creating a new path. And then the remaining slices there, REM plus REM I plus 1, is going to create a new version of that REM by removing the character index I. God, this is so hard to explain. The slice operator then will create a new list of everything that's remaining to look for in the next call.
So what's
Does that
being
make sense?
passed through the first time? Is it the whole list, right? It's A, B, C, D, E.
Yes.
And then on the next pass, is it cutting something out?
Yes.
So what is it cutting out? Is it cutting E out?
It's gonna cut a pattern every time. So it's gonna go through, look, cut, uh, I don't know where it cuts. If it cuts from, I think top down, I think in this one.
If we do a print statement before and after the cut, maybe that could help visualize.
Okay.
Yeah, 'cause the way I see it right now is it just cuts it out, but how does it get like the different like repositioning the indexes. So like instead of A, B, C, D, it'll do B, A, C, D, E. That's where I'm confused too.
Is that where the I plus one? Is that where it
That's what,
happens?
yeah, for sure. Um, I'm not really sure I follow what you're saying, but
Like I said, if you put the print statement in there and just like show us the development of each,
sure. What do you want me to print?
let's see here, where would that work best?
Should have to go in here, right?
Yeah, probably in the for loop.
What do you want me to print? Rem or
Whatever the code, the password it's creating.
Yeah, print every character in that formula. So print P, print rem of I, print rem of colon I, rem of colon I plus one.
will that print that way?
It will, yeah.
Okay, probably should have went back to cat for this one. All right, so A list, B, C, D, E, A, B list, so on and so forth. I've never done it. This looks interesting.
So it does pass in the first one, passes an A.
Then B, then AB plus C, then ABC plus D, then ABCD plus E, then ABC plus E. It just
Oh,
Justin, can you share your solution in Slack so anybody that's curious on investigating later on can toss it into their terminal and
sure. I sent it to Umar last night. I'll just copy that over. Wish I could explain it better, y'all, but maybe Phyllis has the terminology. I sure don't.
I think your approach was very interesting because it's hard to identify what the base case was, and it looks like it ended
Well, see,
whenever you ran out of things to loop over. So that's
there's
and
really no base case, like a
yeah,
traditional base case. And I've noticed that's kind of a common. So when I was doing this, I looked up common issues with strings and recursion. And that's often the case with a string type recursion is there may not be a traditional quote unquote base case. So I kind of went off some of the research I found from there and used the snipping method of doing it is what I got it from real Python and they call it the snipping recursion method. So that's actually where this came from.
I'm not sure what you mean by a traditional base case, though, because essentially, if you think about the logic that's happening at each iteration of the recursion, that's a case. The base case is always just going to be the simplest version of that.
Right, but I guess like what I'm talking about is like what we're thinking about as students right now. But like what this serves as the base case in that it captures every valid combination without further, without any more recursive calls.
Hmm.
But at the same time, it's not like a zero or a one or it's not like it doesn't seem like a switch to me when I wrote it.
yeah, based on the code, it looked like the recursive call stopped when you ran out of things to loop over. So when the rem list got to zero, so maybe it's like when there's nothing remaining that could be called the base case.
Right. I think how you said it the first time, Justin, like that was perfect. It made sense.
All right. I don't know. Now I'm getting confused, y'all.
All right. Well, it's recursion, so it's inherently confusing. We can continue to play more around with it later on. Um, let's actually, yeah, let's do just one more thing of recursion before we jump into classes. It's quick, I promise. It's like the same answer as Omer's, but I just want to show one thing. So let me share my screen and make sure I've got the right one pulled up. Okay. Cool. So we saw with Omer's solution that he's basically taking, let me see if I could try to talk through this. Where's his solution? Let me set it here. Let's look at it so it's all nice and pretty. Let's save first. Refresh. All right. So Omer's solution. He is defining a function called sum of nums. He's passing in a number. His base case is, I don't know why the hell it's doing this. His base case is if the number input is just 1 digit long, then just return the digit. So his first condition is essentially a translation of that, right? Because any number less than 10 is only 1 digit long. And so that's what gets returned. And we know it's the base case because we're no longer calling the recursive function. We're returning a final result. Now, the logic that's happening here is he creates a variable called first digit string. And again, none of this is going to be hit when we get to the end because the return is going to end the function. But when this condition is not met, this first digit string will be equal to this function string, which will convert a number into a string. So whatever you pass in, 1, 2, 3, 4, 5, that gets converted into a string. And the way that strings are treated in Python, you can iterate through strings the way you could iterate through lists. You cannot iterate through a number. So if there was like a 5-digit number, it would fail. It would throw an error. That's why we use str to convert it to a string. And then we're accessing the very first part of that string, so index 0. So that's our first digit string. He then takes first digit and he reconverts it back to a number, an int, from a string character. And that's what this function is. And the recursive step is to return this function, sum of nums, with what he calls all digits except the first, where he just slices off that first digit. And he is returning the sum of that first digit plus the result of the next recursive step. So if we were to take this, let's toss it in our terminal. Whoops. Doesn't like all these extra lines. Still doesn't like that. Okay, let's see if it complains. Cool. So let's now take this. Let's do sum of numbers. 2, 3, 4, 5. We get the result that we want. And let's see if we could add a print statement somewhere in here. Unless, yeah, let's do that. So first digit, and let's turn this into an F string. And all digits except first. Save. Let's repaste our method. Oof. I'm missing a quotation. Okay, and now let's run this again. So this is the result. Does anyone want to take a stab at explaining how we get to 15 from here? I'll give you a hint. It has to do with stack trace. One thing that's really hard to visualize about recursion is, I don't know, like maybe the ephemerality of like all these numbers, right? Because we're seeing return first digit, and then we're kind of inclined to think, okay, at this point, the first digit is 4. But how do we get from 1, 2, 3, 4 over to 15? If you think about the stack trace is essentially like this, you can think about it as like the log cache for the interpreter or the compiler. Behind all of this code, there is a compiler that is running everything. And so every time it iterates through one case, it's running this function, right? So behind the scenes, we actually have the value of the sum being added because we're really adding all of these lines together at the end of the day. And that's how we get to this 15. I don't know if that's a great explanation, but
The way I've been trying to wrap my head around it is after you run the first iteration,
mhm.
I mean that iteration isn't resolved yet
Mhm.
because you have first digit and it's sitting there. It's found that first digit in the code that we're looking at and it's sitting there. Plus running it again with a different argument it's passing through because you've already removed, what is it, number 5 or whatever it is.
Mhm.
And now it's going on to the next one. And then that one's not resolved until it does the next one, until you get to the end and it says, okay, now we're going to return only one digit because that's where we're at. And then it
Mhm.
goes that digit plus the iteration that was before it. And then that combination of digits plus the iteration that was before it, all the way until you get back up the stack, as you so to speak.
Exactly. That is perfect. That's exactly how it is. And again, it's kind of like hard to like conceptualize, but once you get the hang of it, make the realization that, like you say, Sean, it's not resolved, then it's a little easier to start to digest. So one last thing about this, well, we see the iterative solution here. This could be a starting point for how we solve it, right? Because the iterative solution is really easy. We know that to add all of these together, we just iterate through this entire number where each digit is an index in a list, and then we just add all of those values together. So iterative is super easy. Getting to this from there is a little easier than trying to get to this from, I don't know, like let's just say spoken English, right? And I want to show one more thing, and this is kind of like a simplified version of that. So where Omer had first digit string, first digit, all digits except first specified as variables. We could bypass all of that with some simple math. We know, for example, if we divide, well, if we use the modulo operator, which will return the remainder of division equation, if we divide by 10, it will always be the last digit, right? And if we use the floor divider, the quotient will always be everything but the last digit. So we could essentially do exactly what Omer was doing in his 3 lines of code without creating any extra variables by running through some math, as we call the recursive function. Okay, so that is recursion. We'll see if we might talk about it a bit more during stand down. But we are going to switch gears to classes. So
Can I just ask quick? Yours went backwards, right? And his went forward?
actually, no, we went in the, did we go in different directions? Or I start some, no, that's not.
Isn't he starting with 1 and you're starting with 4?
If number is less than 10, and I think he does as well. Let's ignore this for now.
Yeah, last night he started doing it backwards and then switched it to forward, top down.
Interesting. Okay. Yeah, I copied and pasted this one from Slack.
When he first started doing it, he tried doing bottom up and ran into some problems, so he switched it.
But isn't that what 10 modulus or number modulus 10 ends up giving you is the 4? Never
Right.
mind.
It will be the last, yeah, it will be the last digit. So like if it was 1, 2, 3, 4, it would be 4. Oh, right. And you're saying Omer's taking the first digit. Right. Okay, I see. Yeah.
Yeah, if you would post that one too, it's nice to look at them both ways.
Okay. Yeah, I'll share that.
Thank you. Appreciate that.
Right. Okay. As you have probably noticed, because I didn't have an agenda put up, I don't have slides for today. So let's see. I'm just gonna copy paste some stuff in here. I guess we could tend to use this. Okay. What's that? Reload it. All right. So yeah, I saw some interesting stuff in your solutions from yesterday, and it's cool to see a lot of that experimentation. Some of it is getting ahead of where you're currently at. Like, what is it? Superclasses and subclasses. I think I saw a few examples of that. And to Jordan is going to be covering that in more detail tomorrow, and we might take a look at it as well for a sec. But let's start with some of the examples from yesterday. And so if we go with this example, oh, be too much. Well, before we dive into all of this, let's take a breather. Let's step back. Somebody explain to me what classes are.
It's a blueprint, a template for making, I don't know, for storing data, so to speak.
Yeah, it's a blueprint, exactly. It can be instantiated, which essentially is kind of like running through that blueprint and creating the end result or the product. I have any other questions? I can't remember. But let's see. So if we look at this example here, we've got a user, we have a class variable, and then we have this dunder init method. And like you learned yesterday, dunder init is like this super magical method that essentially initializes parameters so that they will belong to the instance and not just the class. So in this case, we're using the double underscore init method. We're passing in self because it requires self. Self is a keyword, a special keyword in Python that we'll talk about more in a sec. And then we're passing in these placeholder parameters, name and email. And we're saying instead of assigning these variables to the class itself, we want to assign it to the instance of this class. That's what the self keyword does. It binds things to the instance rather than the class. And so here, when we see we're instantiating this user by calling the user and then passing in values to fill in these placeholder parameters, we have created instances that all have their own unique values for these variables. But one thing I liked about this example is how it shows this line right here, person2.vip. So this student was overwriting this class value for user manually, and that allows this user to, when running through the list, come up with a different result for person 2. So let's actually run this in our terminal. With the for loop, we're iterating through the guest list, which is a collection of the person instances, or the user instances, I should say, that are named persons 1, 2, and 3. And we're printing an email and the VIP. We see that we have the default value of the class variable assigned to persons 1 and 3, but we have that value overwritten for person 2. So, right, that is the difference between your class and your instance variables. When you're writing your classes, that's just something to keep in mind. Ask yourself, like, is the value that I'm trying to create here supposed to be unique to every instance of this class? Those are the kind of leading questions you're going to want to ask yourself when designing classes. Another example that I saw that I thought was really cool was one that utilized underscores to create private variables. And I don't know, did Omer cover private variables at all yesterday?
I had brought it up, but he said not to worry about it right now.
Okay.
I am kind of curious as to what that is, just because it was brought up, but it wasn't.
And
I mean, I don't know if I'm the only one that doesn't know what that is, but I don't know what that is.
it was brought up in FOP, and they made it sound like it was important. At least Gmo did, and the one I watched in 2022.
Is it important? Man, that's a very good question. That's super subjective. I've heard, I guess I've heard both opinions. I think it's good to know. You're going to come across it eventually. And so it's good to know what it means. Will you use it? I don't know. Let's paste this in here and let's talk through what's happening. So we have a user and we have, just like above, a name and email address. But what we see here is an underscore in front of name. That makes this a private variable. We have this double underscore in front of email address. We'll talk about that in a sec. But with this underscore, we're essentially saying name is a private variable. And there's some misconception about this. It's private, and then you might think that it's no longer accessible or something along those lines. It's not actually protected. It's more of, how should I explain this?
Is it just a way for like developers to talk to each other like, hey, this isn't to be changed?
Exactly. So it's, yeah, a communication with other developers rather than the compiler itself, for example. But it does change some behavior, right? So if we create this bev user and we try to call bev.name, we're going to get that error. Now we could still call this method bev.get_name and it returns the name because that logic was written to access this .name. And we could still actually get that name if we just knew to prepend it with an underscore. So it's private, but it's really not, right? Like we could still access it. Now, this double underscore is called name mangling. It's just, I don't know, even more private, I guess. And it just has slightly different behavior. But I think this actually is a lot more practical than private variables itself. And we'll look at that a few examples later. But for now, let's see how we access it. We can't just do bev.__ email address because unlike private variables, it's like got this extra layer of safeguards. It's kind of like you need to know an extra step to a secret handshake in order to unlock it, right? So to access any private variable that has been name mangled, you really just have to specify the class that it belongs to. So if we type user __ email address, then we can see bevdevs@femalecoder.com. So that's private variables in a nutshell. Once you know how to access them, that's like essentially the key thing to remember. And as for a use case, let's see if we do have that example right here. So this is a superclass, also known as a parent class. Again, Jordan will talk about this more tomorrow. Basically, in addition to instantiating classes, you can create subclasses out of those parent classes. And you just use simple parenthesis notation to do that. When we define the child class, we're passing in parent. This is how we tell Python, hey, we want a subclass of parent, and we're going to call it child. Now let's look at some of the differences between these two. We have self._name. So let's create a child. Child equals child. Whoops, if I could spell. And if we do child._name, we get the child's name. But how do we get the parent's name? We can't. Because we didn't name mangle, we have no way of accessing the parent's name. It's been overwritten, essentially. So name mangling serves this extra layer of protection, I guess you could call it. It prevents the overriding of what might be important or critical variables. So you, as a developer, you are concerned that your junior developers beneath you are going to mess up your code. You've been coding for a while, so you know better than all of them. And to make sure they don't do that, you use the double underscore on your most important values. And that allows you to do things like this. If we do child secret, again, the syntax for name mangling requires us to specify the class name. So we would have to do child__ secret. That's the child secret. Because we name mangled this variable, we could also access the parent's secret. So that's the most practical use case for private variables name mangling. It creates a way for you to access variables or values that may have otherwise been overwritten. And it works for methods as well. So let's do child.reveal_name. It reveals the child's name, but not the parent's, because the method was overwritten. Now, if we have, was that really my example? If we have, yeah, I guess that's, I don't know if that's the example I wanted to show, but notice we have a private reveal secret for the parent, but a public reveal secret for the child. that prevents that from being overwritten as well. So if we do reveal secret for the child, it's going to reveal the child's secret. And we could use for, sorry, go on.
That's only because the functions or the methods are named differently with that private in front of it. That's why it's not getting overwritten.
Exactly, exactly.
Can we elaborate on overwritten? So these are being stored in the magic of dictionary, right? So is it, at least I'm thinking wouldn't it be underscore underscore dict that these are getting saved at? Or where are these being overwritten? Just in memory in the call trace? Like,
Exactly. Yeah. We're
okay.
not creating any dictionaries at all. These are just the instantiations of the class. And so they are only held in memory as far
Well, I
as,
think aren't all instance variables stored to a dictionary no matter what you designate?
are you talking about this? So like, let's say through that child, we could access like any,
Right, you see how underscore underscore dict.
Mhm.
I'd be curious to know what was in that.
Yeah. Well, we see the underscore name. And so it overwrote the parent's underscore name. We
Okay.
see an underscore reveal secret that came from the parent, right? Because the child's reveal secret isn't private, it doesn't overwrite it.
So at any point, does the trace stack actually dump into something, or does it just stay in live memory the entire time?
It stays in live memory unless you call it.
Okay.
So when you pass in the parent as a argument into the class child, you're essentially taking all of those methods from the parent into the new class. And if
Exactly.
it has the same method name in that new class that you're copying it from, it's going to change what that information is in that method.
Exactly. Exactly. Yeah, and again, this is a sneak peek. This is really just supposed to be a sneak peek for superclasses, subclasses, because Jordan's going to cover it in more detail tomorrow. But I had to show it in order to demonstrate some of the use cases for private variables. So that's private variables. Let's see, what's next? I guess I had some more examples, but that looks like it's more or less all the same. Okay, so let's talk about Dunder. We've already talked about Dunder init. So you know that it's a special method that utilizes the double underscore Python constructor to instantiate new classes. I think I already said all this a little earlier. I guess to reiterate, I did say this earlier, but it doesn't actually return anything, right? Its purpose is only to initialize the class. This is why we have to use the self keyword to bind attributes to the specific instance when we instantiate the class. Okay, what else was next? All right, I guess we're going to talk about Dunder main. So double underscore main. You might see this kind of excerpt a lot. If name equals main. If you see this in a Python script, the easiest way to look to remember it is basically the code will only be ran if the script is directly executed. That way, you could safely import this script into other scripts without worrying about logic outside of a method running automatically. There are other, I guess, creative use cases for it, but that's its main purpose. And if we use the type method, the built-in type method, we could use this to take a look at classes and instances, and we should be able to see different results, right? Bev is an instance of a user class. So we see underscore underscore main dot user. If we just do the class itself, we'll be told that it's a class. And if we import a module from another script, and then we instantiate that method or class, I should say, in this case. So Bob is an imported user from this other script named Bob. And if we do the type for Bob, we're going to see my module.user as opposed to double underscore main dot user. Double underscore main is essentially referring to the script that you're in. So if you're executing the script, it will run the logic because name equals main, name being a property of this script, I guess, to think of it that way. And when you reference classes that were instantiated from the script, they'll also be prepended with double underscore main when you inspect them using type. Okay, any questions on any of that so far?
I'm not even sure that's English at this point.
Yeah, you lost me at the double underscore main and how we could use it, honestly, or what its use case. Because I guess I'm understanding it. It only runs when you're running that script, meaning like that whole file runs. That's kind of what's going through my head right now.
Sure. No, let's backtrack a bit. When you write a Python script, you could write in so many ways, right? You could write logic within classes, within functions, and they won't get called by anything because you're not calling those classes or those functions. Or I should say they don't run until they are called. But if you write some logic outside of that, that's considered global logic. It will run when you run the script. And that means if you import this script from somewhere else, like let's say imported user has, where do I have imported user as? From my module, I don't know why I can't see that. Oh, yeah, because that's the name. From imported user, that's weird. This is a class. If I had logic outside of this, like, I don't know, Sean is a user or instantiating user. Or I should say Sean equals, sorry. What happens is this will be run when I run my import, right? So if I want to prevent this logic from running whenever this module is imported somewhere else, because like, let's say maybe this module is used by other scripts, then I can do my if name equals main and indent. So I'm essentially saying only run this logic if we're directly executing this script as opposed to importing it from somewhere else. Does that make a little more sense?
Yeah, kind of. I think that's a little beyond us right now in terms of like importing modules and stuff like that, but I could see what you're saying.
Okay. Does it make sense in the context of the classes, how when we create a class from the script we're in, when we inspect it, it's double underscore main?
Yeah, for me that makes
Okay.
sense.
Yeah, I think this is the more important thing to know about it right now, that it might be hard to kind of conceptualize the use cases for this kind of thing, but like let's say you were troubleshooting some code, you're going down a very long stack trace of errors, or not even just errors, but like at different lines in a stack trace, which is like telling you that code is coming from somewhere else, right? Knowing these kind of things will help you navigate a little more efficiently. Like if for whatever reason the code had a user class coming from different scripts, when you inspect, you'll know that the user you might be looking at or trying to troubleshoot is different than a user coming from a module. So that is double underscore main. Let's see. So let's kind of go back to methods overall. I think I've already seen some of you writing methods inside of your classes, and we saw a few examples of that as well. Let's see. In this example, man, I wrote this, but I always still kind of forget what's going on. Okay, yeah, let's just look through this. I don't know if we have to actually run it. We're creating a dog class. We're setting a type called Labrador, and we're giving it a name. Are these class or instance variables?
Class,
Exactly. Why?
because it says it right there. No, because they aren't within the init method, so they're not instantiated by you passing that argument into the class when you call it.
Exactly, exactly. Oh man, I must be going blind if I totally missed that. But yes, exactly. That is why they are class variables. And the importance of this is when you start to manipulate some of this data, it is the way that you update things that's going to update these values. So here we've already instantiated two different dogs, dogs A and B. We see that they have the same type because they inherited from their parent or the blueprint class that they're an instance of. And their names are different because these are class variables and we're passing in the value that we want for that name, which uses the self keyword with the double underscore init method to bind it to the instance. But if we were to manually change the name for these instances, it has no effect on the original name of the class itself. Now, if we change the type of the class, it's also going to change for all of the dogs. So actually, maybe we should run that just to see. And let's do these two lines. And now, if we, I think we're updating type, right? If we change the type for the class, I don't know, dachshund. I don't know how to spell. Is how you spell it? Probably not. And then we look at dog a dot type again, we'll see that it changed. And I really can't type. Cool. So that's class and instance variables again. Okay, defining a class versus or method versus calling a class or method. Okay, I think what all I wanted to illustrate here is when you are specifying parameters inside of a class, you're requiring them. And so if you try to, here we instantiate the dog, so we have a dog that's an instance of the dog class. If you try to call that method without passing in the parameter that's required, it's going to throw an error. So some ways to get around this is to set a default argument. At least that's what I thought I was trying to do here. But it looks like I'm also trying to do something with size. Oh yeah, here. We write a new method called set size. It's requiring a size, but we're also passing in a default value. So we could call dog set size without passing anything in. It won't error out like it would if we were to call update color without passing something in because it has a default variable defined. And I think we saw
For that on the default values, because I was questioning when would we want to use the class variables, and so I was wondering, could the class variables be used to set as the default, or is that a bad practice?
it depends on what you're trying, right? Because if you want your instances, yeah, that's a okay. If you use a class variable, yes, you can update that value for any instance of the class. If you use a default value, passed into a function with self, that's binding that value and variable to the instance. The end result is essentially exactly the same, but you have an extra layer of protection in place, right? Because if we were to try and update, if we were to update that first class variable, it will overwrite the new values for the instances. We would have to re-update values.
Oh, okay. Okay. Thank you.
Mhm. Okay, so that's probably the important thing about default values for both class and instance variables. Okay, this isn't even in, I don't even know if this is in the README, the class method decorator. So we could use a decorator to specify a class method. So this class method looks like we're passing in this CLS, which is essentially like a variation of self, and we're setting a breed name, and then we're setting a name mangled breed. I don't remember where I was going with this, so give me one sec. Okay.
Looks like you're just changing self for CLS. Is that a thing? Like,
When you're using the class method, yes. But I don't remember why I added. I must have. I think this must have been like one of the last things that I added last night. Yeah, this might actually be like unfinished. I don't know if I.
What reason would we not use self?
What reason would you not use self?
yeah, because I'm looking at the README now, and you like did a decorator with class method,
Mhm.
and you have a new definition, change color, and you put CLS instead of self. So why CLS, I guess, is a class as a method within the decorated class method?
Yeah, and I'm trying to remember
Like,
why.
what does that do? I guess I think that's what our question is. What is CLS doing?
So it's going to treat it as a class method. So when you run this, it's going to update for all of the instances of the class and not just like the instance itself. So you would use self to bind the variable and the value to the instance. But here, if we wanted to have the ability to also update all of the instances programmatically, we would use a class method to create that method, and we would use class instead of self. It's going to affect all of the instances.
So you're creating a method within the class you created to change all instances through whatever, like I guess for us, the terminal, so to speak,
Yeah,
for
yeah,
now.
through this method. So if I were to call this method in the script or whatever, it will update the breed for all of the class, all of the instances of this class.
I guess that's a more secure way to change your variables, right? Because if you use a class variable, anyone can just go in there and do like dog a dot whatever the class variable is. Whereas this way, you use a method to change it.
Exactly, exactly. And because we're using the double underscore, that's name mangling, it's that extra layer of protection, right? So even if somebody made a subclass of this dog and they overwrote this set breed method, we could still access the parent's breed using dog underscore breed. right, how's everyone feeling?
I just gotta play with it.
Confused.
Yeah, sure.
All right.
Yeah, I agree with Jonathan. It's a lot to take in.
My bad.
So my question, um, so we have the methods that are in the class itself, but those methods are not class methods, even though they are a part of a class. But then we have it to where we have these methods that are class methods when we use the decorator. Um,
So
is that so? What are the other methods in the class then?
they're methods that belong to the instance, right? So when you run the method on the instance, an instance method, it's not going to affect all of the other instances, just at one instance that you called. So dog A dot set breed will only affect dog A. Now, if we're calling, if set breed was a class method and we do, well, you wouldn't call dog A dot set breed if it was a class. We just run it on the class itself. But that's how you would update all of the instances.
Okay, so the methods in the class that don't have the class method decorator, they're just the methods for the instance of it. And that's it. Okay. All right. Thank you.
Okay. Yeah, I know the README today. I don't think it covered double underscore private variables in too much detail. I thought I
It
thought it
doesn't talk about them at all.
right. Yeah, I saw your example, Sean, from your code, and I thought it was like a nice thing to fit into the classes because there is kind of a lot of overlap, right, with how they're used. So if this is a lot, just back up a bit, focus on whatever is in the README, double underscore private variables, name mangling, just throw it away. Save it for another day. And that was the end of it. That's all I had to demo. Your challenges today is an extension of the challenge from yesterday. So you're going to take that same app user, and you're going to add some additional functionality. If you were working in groups, go ahead and go back to those same groups. And how many breakout rooms did you all have open?
I think we worked in pairs last night, right?
Yeah.
Okay. Well, I don't know what your pairs were, so I'll just open up a bunch of rooms and let you all choose. And we've been here for a good while, so feel free to take a 15-minute break before you come back to work on your challenges.
The Armstrong numbers challenge, which we've already